In this video, we'll be comparing the graph of y equals 10 to the x to the graph x equals 10 to the y. So our first table of values here will represent an exponential function with base 10, and the values in this table will represent a logarithmic function of base 10. So my original table of values gives me negative 2 to positive 2 for x, so I'll need to plug them in as exponents on 10 to get the y values. So plugging in a negative 2, that will be 1 over 10 squared, which is 1 over 100. Plugging in a negative 1 gives me 1 over 10. Plugging in 0 will give me a value of 1. Plugging in 1 will give me a value of 10, and plugging in 2 will give me a value of 100. So we can see those plotted here already. And we can see the point there of 1 for the y value, 0 for the x. We can see the point at x equals 1 and y equals 10, and we can see those other two very small values back here of a tenth and a hundredth as they really approach the x-axis or the value y equals 0. We don't actually get there, again, because this is an exponential function and we have an asymptote. For the logarithmic function, what we essentially have done here is that the x and y values, or the domain and range, have switched. So the x values now would be the y values from the exponential function. So I'm going to have a hundredth here, a tenth here, 1 here, 10 here, and 100 here. And that will correspond to the negative 2, negative 1, 0, 1, and 2 that I had for my x values in the first graph. So when I switch the x and y values, what I've essentially done is created a reflection in the line y equals x, because all we've done is change the domain and range. So if we plot the new function, and I take the points that are easy to read here, say x equals 1 and a y value is 0, and then a value of x equals 10 and a y value of 1, x equals a tenth and a y value of negative 1, so we'd be looking somewhere around here, and then we'd be looking somewhere around here. So what we have then is that logarithmic function, which would look something like this. I'm going to make a little adjustment here because my graph shouldn't technically cross the y-axis. So that's about as good as I'm going to get sketching with the pen I'm using here. But what we can see is that the graph in red here is a reflection right across that line. And again, that occurs because the domain and range have been switched from an exponential to a logarithmic function. So where we couldn't cross 0 for the y values for an exponential, we can't cross 0 for the x values for a logarithmic function.